The ages of the universe, our galaxy, the solar system, and the Earth can be estimated using modern scientific methods. The age of the universe can be derived from the observed relationship between the velocities of and the distance separating the galaxies. The velocities of distant galaxies can be measured very accurately, but the measurements of distance is more uncertain. Over the past few decades, measurements of Hubble's expansion have led to estimated ages for the universe of between 7 billion and 20 billion years, with the most recent and the best measurements within the range of 10 billion to 15 billion years. The age of the Milky Way galaxy has been calculated in two ways. One involves studying the observed stages of evolution of different sized stars in globular clusters. Globular clusters occur in a faint halo surrounding the center of the galaxy, with each cluster containing from 100,000 to 1,000,000 stars. The very low amounts of elements heavier than hydrogen and helium, these stars indicate that they must have formed early in the history of the galaxy, before large amounts of heavy elements were created inside the initial generations of stars and later distributed into the interstellar medium through supernova explosion. Estimates of the ages of the stars in globular clusters fall within the range of 11 billion and 16 billion years. A second method for estimating the ages of our galaxy is based on the present abundance of several long-lived radioactive elements in the solar system. Their abundance are set by their rates of production and distribution through exploding supernovas. According to these calculations, the age of our galaxy is between 7 billion and 16 billion years. Thus, both ways of estimating the ages of the Milky Way galaxy agree with each other, and they also are consistent with the independent derived estimated for the age of the universe. Radioactive elements occurring naturally in rocks and minerals also provide a means of estimating the ages of the solar system and Earth. Several of these elements decay, with half lived between 700 million and more than 100 million years. Using these timekeepers, it's calculated that majorities, which the fragments of asteroids formed between 4.53 billion and 4.58 billion years ago. The same radioactive timekeepers applied to the three oldest lunar samples returned to Earth by the Apollo astronauts yield ages between 4.4 billion and 4.5 billion years, providing minimum estimates for the time since the formation of the Moon. The oldest known rocks on Earth occur in northwestern Canada. It's 3.96 billion years. But well-studied rocks nearly as old are also found in other parts of the world. In Western Australia, zircon crystals encased within younger rocks have ages in old as 4.3 billion years, making these tiny crystals the oldest materials so far found on Earth. The best estimated of Earth age are obtained by calculating the time required for development of the observed lead isotopes in Earth's oldest lead ores. These estimates yield 4.54 billion years or billion years as the age of Earth and of meteorites and hence of the solar system.